Hi class. I'm going to do a quick review on the questions for quiz 5. First question is, when does current flow in the PMOS transistor of a CMOS inverter? And the first thing to realize is that current flows only during switching. So there's got to be a change on the input. And the next thing to realize is that the PMOS only turns on when the input goes from high to low, or from 1 to 0, if you want to picture it that way. And the next question is, if you created a MOSFET that always has the channel present, how would this restrict the digital operation? Now, of course, there are transistors that can be made this way, so you have to think about this. Of course, the gate will have no control any longer. So it's only the drain voltage, or the drain to source voltage, that makes the operation. It's not really a transistor controlled by a third element anymore. Okay, if you start with a P- wafer of silicon, what doping is going to be required for an NMOS source and drain? So P-, remember, represents a lightly doped P-type silicon. In order to have an NMOS transistor, the source and drain need to be highly doped N, or call it N plus doping. And that's all you need to do is put in a high doping of N in the source and drain regions only. And that will do it. Okay, next question. If we start with a P- doped substrate, again, that means lightly doped P doping, P-type silicon. How can we form a PMOS in there? This gets trickier because the P- substrate cannot form a channel that we would like. We need an N- doping. In other words, lightly doped N. So we form an N well where we're going to put the PMOS transistor. So we actually have to do an extra step in the process, and we counter dope to make sure that we have enough N doping that it counteracts the P doping and then gives a little added N so that it's lightly doped N type in the end. Then we can build our PMOS transistor, which will include source and drain that will be highly doped P. Okay, next is, which region of operation is used for MOSFETs in digital circuitry? And by far, the most popular region of operation that we've talked about already is saturation. And that is a nice place to operate for digital because the drain voltage can change, and yet we don't have any impact on the drain current. Okay, what limits the current flow internal to the MOSFET? This is the R on value, or the RDS on. That's the resistance of drain and source, and between the drain and source, which is the channel. So all those resistances add together, and we also include the word on usually, so R on or RDS on. And those values are typically well below 1 ohm. Like, it's desirable to be in the milliohm region so that the MOSFET itself is not being the main current limiter. We would use resistors in the circuit to pick the exact resistances that we need. Okay, the last question is, how could power expended in a CMOS inverter be calculated? Now, power is only expended during switching, and it's possible to calculate it, of course. The WHO text gives an equation, which is the right answer. And of course, the trick is to find out all the values of the things, the factors to plug in to that equation. And then, of course, you can calculate it. Now, there are some simpler equations and there are some more complex equations, but in fact, the power could be calculated, and that can then be used to estimate, if you have 1 billion transistors in your circuit and you calculate about how much of the time they spend in switching, like what percentage of activity level or what percentage of on time, duty cycle, all those things that we're used to, then you can calculate. You just have to have the nice equation handy and enough values to plug it in. Of course, you would normally have a computer software take care of that. So, okay, that's it. See you next time.